inverted gear. Now suppose in this diagram, that dedendum, if we increase the dedendum, and it goes below the base circle, due to increase in the dedendum, that dedendum circle goes beyond the base circle. Dedendum circle goes beyond the base circle, and if that dedendum circle goes beyond the base circle, that profile below that base circle should not be involute profile. That profile below that base circle should not be involute profile, and if such gear meet with or engage with that another gear, in such case that another gear tooth tip undercut that gear having dedendum below the base circle, in such case that tip of the tooth undercut that profile of that engaging gear, tooth. So in that case we observe some undercut, due to engagement of the two gears, So second gear tip surface of the tooth undercut that engaging gear due to change in the dedendum circle, in that engaging gear. So in such case that phenomena, when tip of the another engaging tip of that gear tooth undercut that engaging tooth, that is called as a interference or undercutting of that involute gear. So such phenomena, when tip of the tooth undercut the root of that particular mating gear, is known as the interference. And due to such undercutting, that earlier failure of the tooth will occur, and also bending moments and stresses also increases. In such cases. So in this interference, due to that undercutting, earlier failure of the tooth will occur, due to as undercutting remove that particular material. Earlier failure we can observe in such cases. Maximum bending moment and maximum shear stresses also observed in such cases. And as that profile doesn't remain as a involute, as that dedendum circle extend that base circle, profile should not be remain as a involute. And such phenomena, when the tip of the tooth undercut the root of the mating gear, is known as interference. So this undercutting should be avoided. Now this is the case we discussed, as that these are represented as undercuts. These are the represented by undercut. So this gear or this gear below, observe here, that gear shows as this undercut. When this another gear engages with this gear, So in this interference case, this undercut will observe. This will observe in this case. So this it cause earlier failure, it maximize bending moment and maximum shear stresses, and it weaken the tooth by removing the neutral, and profile should not be remain involute in case of that undercutting of that gear, So with this now we move further for the derivations in this interference cases, So we consider this diagram. Consider this diagram. So in this diagram, two gears are come in contact. With the center O1 and O2. And these gears, these O1 represent pinion, the center O1 for this gear, and this particular gear is considered as a pinion. This gear having center O2 is considered as a wheel or gear. Now these two gears are engaged. And these having some base circles. For this gear having center O2, that base circle is represented here. Addendum of that this case addendum is represented here. That addendum is base circle is represented by this curve. Addendum is represented by this curve. Addendum of this gear having center O2 represented by this curve. And if we change this addendum, that changed addendum circle is shown here. For this gear having center O2. So this is base circle. This is the addendum circle. This is the maximized addendum circle. When that addendum will be changed, for this gear having center O2. Similarly for gear, or here in this case that gear is considered as a pinion. This gear is considered as a pinion with center O1. Now this will be the base circle. This will be the base circle for this pinion. Now this will be the base circle. Now this will be the maximum addendum. This will be the maximum addendum of this gear having center O1. This will be the maximum addendum, and actual addendum is this one. Actual addendum circle is represented by this curve. Actual addendum of this pinion is represented by this curve. This addendum maximum extended to this circle. This addendum is maximum extended to this circle. So to study this interference, we consider these cases. Original addendum for each gear. That addendum is extended. To study that interference in this involute type of gears. So original addendums are changes. Original addendum circles now extended to another value. Original addendum circles are extended to another value to study that interference case. Now in this diagram, here represented for O2 and O gears having center O1 and O2. Base circles are represented. Addendum circles are represented. Extended addendum circles are also represented. For this pinion also base circle is represented. Original addendum circle represented. Extended addendum circle represented. And for such case that path of contact will be represented here. For such cases, that path of contact is represented here. Now, original case. For original case, we draw a tangent. We draw a tangent to the two base circles. Draw a tangent to the two base circles. For this gear having center O2, for this gear having center O1, to both gears base circle, we draw a tangent. We draw a tangent. This is the tangent. This is tangent drawn to the two base circles. Now these are now cut. These cut at here. These cuts are at here. This L and K. L and K. These are cut here. L and K by that addendum circles. By that addendum circles. Now this L is cut by this addendum circle of this gear having center O1. This M is cut by this addendum circle, and this K is cut by this addendum circle of gear having center O2. So this K and L is the path of contact. K and L is the path of contact. Now this is path of contact represented for the original addendum. For the original addendum. Now if we shift this addendum, this addendum now shifted toward at this addendum, and this addendum now shift to this addendum. This for this gear having center O2, this addendum circle now shifted to this addendum circle. This addendum circle. In that case, this point will be shifted here. K now shifted to the M, and when this addendum circle shifted to this addendum circle, this L shifted to the N. This L shifted to the N. So these are the maximum point. These are the maximum point. M and N are the maximum point below which after extension of this addendum circle above this limit, then undercut will be observed. So these are the interference points. These are the interference point. M and N are represented as the interference point. M and N are the represented as the interference point. So we discuss this diagram. We discuss this diagram here, and usual notations we use here to represent radius of that pinion. Radius of that pinion represented by small r. Radius of that gear or wheel represented by capital R, and that base circle radius for this wheel or gear represented by capital RB. Base circle radius for this pinion represented as a small r p. Like that. Addendum of that gear here represented as a AG. Like this. That notations are the similar or as usual that we also use in the deriving derivations in last video. So this diagram we explain here. Now we move further. For the derivation. Derivation of this case. So with discussion with the diagram, we move further. So we consider in last video we discussed about that maximum. Now in this diagram, original path of contact is a K to L. Original path of contact is a K to L. This will extend. This K now extended to the M, and L is now extended to the N. As we increase that addendum circle of this gear and of this gear, as we increase addendum circles of both the gear, by increasing addendum circle of both the gear, these now L and K now shifted to the L shifted to the N, K shifted to the M, and maximum point. Now maximum path of contact now represented as a MN. Maximum path of contact represented as a MN. Now this is written here. Now this maximum path of contact, we derive these equations. We derive equations for this path of approach, path of traces, and path of contact in last video. So this path of approach, MP represent path of approach. MP, M to P represent path of approach. P to N represent path of recess. P to N represent path of recess. So P to N represent path of recess, and that will be R sin phi. That will be R sin phi. In last video, go through this. MP path of approach is equal to R sin phi. Path of recess is equal to capital R sin phi. And total length of path of contact is a summation of both the path. Summation of both the path. So this is summation of both the path. It will now becomes as a small r plus r sin phi. Small r plus r sin phi. And length of arc of contact is nothing but divide this path of contact by cos phi. Divide this path of contact by cos phi. We will get a length of arc of contact. So divide this quantity by cos phi. We will get a length of arc of contact. Now this becomes as a sin phi, cos phi becomes as a tan phi. So we already go through this derivation. So we already go through this derivation for length of arc of contact. Length of arc of contact. Now we move further. And now here we are interested to find out that array maximum. We find out the array maximum, small array maximum. What will be the maximum addendum radius? What will be the maximum addendum radius for the pinion and maximum addendum radius for the wheel or gear? That we are interested to find out. Now this maximum addendum circle radius of the pinion should be O1N. Maximum addendum. Now this addendum will be for this pinion. This maximum addendum will be extended to this circle. Maximum addendum will be extended to this circle. So this length O1N. This length O1N is nothing but the maximum addendum value. O1N is the maximum addendum value for the pinion. Maximum addendum circle radius of the pinion. This is the array max. Now this we have to find out. Array max is equal to, now this O1N, we consider this triangle. O1NM. This triangle. O1NM. This triangle. We consider this triangle. O1NM. We consider this triangle. Now O1N is equal to, this is a hypotenuse. This is a right angle triangle. O1NM. This is a right angle triangle. O1N represent hypotenuse. And O1N is nothing but square of this O1N is equal to summation of square of the remaining side. So square of the hypotenuse is equal to summation of the square of that remaining side. So O1N is equal to square root of summation of squares of the two sides. And it is represented here. So O1N is equal to square root is represented 1/2. Square root is represented as 1/2. And summation of squares of the two sides. O1M and NM. O1M and NM. Are the two sides of this right angle triangle. O1M and NM. And this is considered here. Now put this O1M. O1M is nothing but RB. O1M is nothing but base circle radius. RB. So this is RB square. And NM now represented as a R plus R sin phi. NM is represented as a R plus R sin phi. This NM is represented as a R plus R sin phi. That we discussed here. This Mn is nothing but the summation of path of approach and path of recess that we already discussed as a R plus R sin phi. That we consider here. And this will be simplified. Now this will be simplified. Now this RB, for this RB base circle radius again we can write as a O1P cos phi. Base circle radius again we can write this RB again write as a O1P cos phi. Consider this triangle, this small triangle. O1PM. So this O1P is nothing but a base circle radius now represented as a RB this RB represented as O1P cos phi. O1P cos phi. O1P cos phi is this. O1P cos phi is this distance. O1P cos phi is this distance. So this is the base circle radius. O1P cos phi. This is the RB. This is the RB. This is the RB O1P cos phi. So this will be written here. This will be written here O1P cos phi. O1P is nothing but R and cos phi. R and cos phi. So this will be RB is written here as a R cos phi. R will be written as a R cos phi. Now, by substituting this RB value here, and simplifying, we will get this equation. So Ra max is equal to RB, R cos phi, R plus R sin phi square, and it is a square root of this all term, square root of all this term. Now O2M, similarly O2M, this O2M. Now calculating this O2M, now calculating for the wheel, for the another gear, or consider as a wheel, that another gear we can denote as a wheel. So O2M, this is nothing but RMX. Again we will consider as a O2M similar to the right angle triangle. We consider this triangle. O2NM, this considered triangle, and this O2N and Mn square are considered. O2N and Mn square. That sides are considered. So summation of squares of these two sides, O2N and Nm, is equal to square of this hypotenuse. So this is the right angle triangle. O2NM. This is the right angle triangle. For this we can write as like this. For this we can write like this. And by simplifying this, we will get similar to this. By simplifying this, we will get R cos phi bracket square plus R sin phi bracket square, and all this term in square root. So this Ra max value for pinion, and this is the Ra max value for gear or wheel. Ra max value for pinion, Ra max value for the gear or pinion. So this shows that maximum addendum radius for wheel, maximum addendum radius for the pinion,